James, robotics and automation from FANUC is a big way of improving productivity and basically saving money. I want to know more about plug and play though. How easy is it to integrate a robot onto a machine of this nature, like this high power version robo drill we've got?
Okay, so this particular robo drill that you've got here has got the latest 31IA B5 controller on it, and the robot that we've got attached to it here is the FANUC M20IA with our latest R30IB controller. Both of these come equipped with FLNet, which we can activate via software on both of the machines, and FLNet runs over Ethernet. So all that's required between the CNC control and the robot control is a single Ethernet cable to get the communications up and running.
Right, so it is as simple as that. It is plug and play. So I take the Ethernet cable, plug it into the robot, and also plug it into the drill, correct?
Straight into the drill, straight into the hub that's supplied with the kit that comes with the drill that's ready.
So the robot turns up, I bolt it to the floor or wherever I'm going to position it, I put the Ethernet cable in the back of that and then into the machine. What's next?
So after that, on the CNC side, there is a page in the manual which lists some settings that need to be changed, which are keep relays within the CNC that just tell it that the robot attached, that it's a left or right-handed door, because obviously you can have a door this on the left or on the right. And it goes through all the safety settings as well, so activates the DCS settings between the two, which allows e-stop and fence circuit to go between the two down the Ethernet cable. On the robot side, on the robot pendant, there's a wizard. So in this particular setup here, we have two drills. So we tell the robot that there's two drills attached to it, execute the wizard, and things like IP addresses, the FLNet communication, and the IO allocation is all set up and ready for you to go.
How complicated is that to do all of what you've just said there? It sounds very easy. Would you need experience in setting automation cells prior to doing this exercise, or is it as simple as you've purchased it, I'm a subcontract engineer, I can get into it straight away?
Yeah, no, it's very simple. The manual which would come with it, there's two chapters on it, one for the drill, one for the robot, and there's screenshots, and it just basically says go to this page, set parameter X to this value, and then carry on through that. And then on the robot side, it tells you how to get to the wizard, which buttons to press, and exactly what you need to set.
This control here then, so this is the screen that's showing us the different elements of the integration between the robot and the drill, correct?
Yes, so we're standard on your normal CNC, you're normally greeted with such a screen as this. When robot interface 2 is activated on the drill, you'll get a page like this, which gives you a graphical user screen to do different operations.
Very quickly talk us through 1 to 6 without going into the screen detail, but what each one roughly does.
Okay, so item number 1, which is system start, which is pretty much exactly what it says. It starts the system as a whole. So this drill, if it was master, would start itself, drill 2 and the robot into a production environment. Manual operation gives you the user manual operation over things like the side door. It even allows you to jog the robot from the CNC. So if you've got a guy that's more adept at CNC programming, he can move the robot around via that screen. Production counter can be reset at the beginning of a shift and count up to the end and log how many parts were made in a set shift. Number 4, which is maintenance, basically says CNC program number 1 in the CNC would activate program number 1 in the robot, or program number 2 if you wanted. And then 5 and 6 are just maintenance screens for signals, so you can see what signal's on in the drill compared to the signals in the robot. And number 6 is more settings that are needed to do on the initial setup.
The communication between the drill and the robot, then you can talk to the robot from the drill, and you can talk to the drill from the robot.
Yes, that's correct. So the robot's got a page on it that you activate, and it will bring up the alarms from the CNC, the actual positions, the IO values, and then there's another screen that allows you to jog the CNC bed around.
Okay, so it's becoming very clear now. It's very easy to actually get the two talking together and in position. How on earth now do let's take for example the part in the machine, tell the robot, or does the robot know where that component is so that we can start production, essentially?
Okay, so from that point you've got the IO set up and the communications going. To pick the part, again, all comes down to the complexity of your tool, but in very simple term, you have to use the robot pendant and move it to where the part is, record that position on the pendant. It's not like G-codes in your CNC, it's what we call FANUC TP language, very simplistic. You just drive it to a position and do shift point, record the position, and the robot remembers it.
It's like a teach. Yeah, you're teaching it to position, picks up the part then, and then you teach it to where to put it?
Yes, so you teach the pickup point, you'd probably teach a point just above it, and then teach a point outside the machine. The robot then plots its own path in and out of the machine based on those 2 points. and then you teach its put down, and again you'd have your put down position, one just above it, and then a point somewhere near the put down, and the robot plots its own path.
I know there's a lot more to this when it comes to fine-tuning for production and making sure you're ready for the production environment. But the two things you've spoken about so far, the preparing the robot to talk to the machine, the interfacing, and then the actual teaching the robot where the part is. Tell me roughly how long those two exercises may take.
Okay, so to get the initial communication set up, you're probably looking at about an hour maybe to make sure it's all working, and then to get a very simplistic program in that just picks the part and puts it, for someone adept at robot programming, it's probably half an hour.
So within less than a couple of hours, this you could be on your way to being in a production environment.
Yeah, certainly, you're well onto your way there, and then after that, as you said, it's just fine-tuning and all the bits that go around it to make sure it's not going to hit something else, and all the I/O comms is correct.
I'm now thinking this far ahead. Okay, so I've got the machine set, everything's talking. What about the health and safety element? I've got a machine shop, I've got a lot of guys working around. What I don't want is that robot coming through that window and causing an accident.
Yeah, so that's a lot of people's concern, is they all have this vision of a robot going somewhere it shouldn't. In the first instance, the robot will only go where it's programmed, but on top of that, we have an extra layer of safety with our DCS, dual check safety position check, where we can create a 3D box and tell the robot that you cannot go out of this box. And if it attempts to go out of that box, so for example, towards this guarding window here, it would cause a category 1 E-stop, so the robot would stop even before it hit anything. And we could do the same with the fact that if the side door's not open on the machine, but the robot's travelling to go into it, again, we can create a switchable zone based on a signal, and the robot would again stop on a category 1 E-stop and not enter the machine or cause any damage.
And all of this is standard within what you would purchase?
Yeah, so within our pipeline robots, it's all standard. The only extra, obviously, is the robot interface software option, which you'd purchase at the time of doing the project.
You're a young guy. If you were running a machine tool or a machine shop and you had a machine tool like this, can you see any reason why you wouldn't have a robot to bring automation into your production environment?
Not really, no. Now as the technology's got better and better, it's obviously come down in price. So in the olden days where it used to be that a robot was probably quite an expensive thing to have and a glorified thing to have, nowadays it's much more commonplace. So having a robot on the side of the machine, it's going to pay for itself within a year by getting rid of the operator off it. And it will work 24/7 through the night. We even have customers that will load their cell up on a Friday evening, come back in on Monday morning, and it's worked all over the weekend on a cheaper electricity rate that you can get at a weekend.
And these particular robots here, have you any idea what kind of weight they can handle? I know they vary in size, don't they?
So this particular one that we have here, which is an M20, so this is a 20 kilo handling robot, but we've got robots anywhere from 5 kilos at our smallest robot up to, well, the biggest one now is 2.3 tons. Obviously a bit big for this machine, but they're the payloads that you're looking at.
I suppose testament to your success is this is actually a sold turnkey installation, which at some point is going to be going into to an engineer ready to go.
Yeah, so this one at the moment is under commissioning time, and yeah, it'll be at our customer within the next month, and we'll be on site commissioning it to get their parts made.
Thank you, James.
Thank you very much.